Okay, today we're going to be going over writing classes weeks 5 and 6. Here is on our website, CS121. We're down here into topics and slides, writing classes. So we're going to be going over this particular slideshow today and do some examples at the end. You have access to this PowerPoint presentation, so I would expect that you read through this on your own. I'm not going to cover it completely. I will just breeze through this. Okay, so writing classes. We're going to talk about the idea that we work in object-oriented programming. We're going to talk a little bit about the anatomy of a Java class and how to create and use various classes. Object-oriented programming. With that, we use things such as classes, attributes, methods, objects, encapsulations to program our materials. So thinking right here, so we want to design a class, just say for instance a class for a Bronco web account. Thinking about what you might need inside this account will be good pre-thought before you decide to design one. So thinking about a Bronco web account, I'm probably going to need to have some methods to get their student ID number, get their phone number, get their address, get their tuition bills, things of that nature. We should also be able to set certain things like maybe their dates of enrollment. We should be able to set their status as far as like maybe grades in a class, or their whether they're an undergraduate or a graduate. So you need to think a little bit about what would be included in the Bronco web account so that you can start to develop these methods and attributes to support that program. So anatomy of a class. We've gone over this a little bit throughout the course. You gotta have your class name at the top, account. We will have attributes of the object. These are going to be your instance variables. We will have a constructors if you want to construct new objects. And reminder that the constructor's new object is always the same as the class name. And then underneath that we will have behaviors of our object. So like for instance a die class, we could consider a single die, and we would need to have things like face value, number of sides, and then the behaviors that we would imply are we would put onto that dice is that we would need to be able to roll them, or roll the dice. We'll need to be able to get the face value and set the face value. Well, do we really want to be able to set that? Probably not. That could be one of those methods that you want to consider, because a user of a dice program, if they had the ability to set the face value, it could negate the program itself. So if you had some sort of a game where if you rolled 6 you win, and the user was able to set the face value of the dice to 6, then it could cause some issues. So thinking about what you want the behaviors is important, but setting a behavior like that would not be appropriate. Like setting the balance of your checking account. That would not be something that an accounting program would want that person to be able to do. We can, a constructor, remember it's named after the class, but we also can do things called overloaded constructors. So if the program was accepting a constructor that didn't have any parameters in there, we would pre-design it to say, okay, we want to have it create a new die with 6 sides. However, you might have a second constructor that takes in the parameters of numbers of sides. So that way you would have a second, if your die constructor had parameters, those parameters would be designed simply to give the number of sides of your die. So you might have like some crazy hexadecimal, hexa die or something like that, I'm not sure. Those are what we call overloaded constructors. Methods of a die class that we might be using, we have roll, get face value, set face value, and then we probably have a void there so there's no return. We have a string method so that we could display your results cleanly. So most classes will provide getters and setters. These are also known as accessors and mutators. Okay, again, we're reviewing right back onto what we looked at earlier, the design of a class. We have a name, attributes, constructors, and behaviors. Instance variables, they're named because the instance, aka object, has its own value of data. So like die 1 could be an instance variable that holds the value of 1. Die 2 will be another variable that holds the value of 3. You'll need to have those so that you can store some data and use that. Variable scope. The scope of a variable is the area in which the program, where it can be referenced and used. So as a general rule, the scope is limited within the curly braces in which a variable is defined. Instance variables have no class scope. They can be used in all methods of the class except static methods. Local variables are defined in the method and can only be used in that method, and that applies to variables as well. So let's take a look at that. Instance variables. They're going to be provided at the very top, and we would want to make those private. And then we have local variables down here, which we were calling local variables are in the method. So right here we have local variables right here, like a new value would be a local method, and it is only active between these curly brackets. Once this roll method is done, this new value does not follow, that variable new value does not follow the program outside of that method. However, these instance variables, base value can be used by this method and other methods following that because it has a larger scope. We have the this reference. It refers the object to itself. It can be used to distinguish the instance variables of a class from corresponding methods. And so when we start creating things, it's going to look a little bit, we'll talk about this reference here. You'll see that here in a little bit. Okay, methods. So we will create a method, maybe say get face value, and if it does not have a void, you will have some sort of a return to that. So when we're getting a face value, you would imagine that you'd want it to return to the user that information of face value. So you'll have a return statement. If it's void, like setting the face value, we don't need to necessarily see that. We just need to know that the value was set. So we just set the value. We don't have a return in that particular case because it is void. Okay, so we have our visibility modifier, public. We have our return type, whether it's void or an integer. We have our method name, and then we have a parameter list. So that's the method header. Method body with return types. Again, if it does not have the key term void, then you will have a return statement. If it is void, there is no return statement needed. You can also use the parameters inside the method themselves. So the method body can use the parameters passed through the parameter list by the name. So we have a method here, set face value, that takes in a value of an integer, and inside that method we can refer to this value here to assign it to a variable. So we do have the ability to use those parameters inside the method. Encapsulation. This is where we get visibility issues, and access to your program. So internal, those are the details of the variables and methods that make up the class. And external, we have the services the object provides and how the object interacts with the rest of the system. So we have to think about what we want the user to have access to. And basically you want to have them accessing your program through, I believe, methods and things of that nature, rather than just having the ability to set variables and whatnot. So like right here, the client should not be able to access the object's variables directly. Any changes to the object state should be made by that object's methods. So the object is self-governing in that case. Okay, so we're going to focus on 2 of the 4 visibility modifiers, public and private. Instance variables and methods of a class declared public can be referenced from any other class, and if they're declared private, they can only be accessed or referenced within that class. So encapsulation, best practices, we want to make instance variables private, and then access those using accessors and mutators. We want to make methods that provide service to clients public so that they have access to those. And any method created simply to assist a service method is also called a support method, and they should be private as well. So those are best practices when we think about encapsulation of our variables and methods. Okay, here's our activity. We're going to design and implement a class. I'm going to make a class that's not here so that you can select any of these on your own, but you will be required to make a class. So what I'm going to make a class of is I'm probably going to make thinking about, I'm going to make a farm. And inside that farm I'm going to have maybe a cat, a dog, and maybe a cow or a goat or something like that. So I'm going to make a farm class that will have the ability to access the cat, the dog, and maybe the cow classes so that they can work together. So that's what I'm going to be making right now. So I'm going to pause this and get my Eclipse going, and then we can take a look at what we got going there. Okay, I decided to start with my first class, a cat class. So I'm going to create a cat object, and thinking about that, so my instance variables, I'm going to put those up here. I'm going to have like a name, and that will be a string. I'm going to have probably maybe a breed, and I think that would be a string as well. And maybe an age, so that's going to be an int. And I might have like a color. Okay. And then I'm going to make a constructor here to create a cat object. And I'm going to say public, so I have access to it. And this is where we can mess around with this here a little bit. And remember, the constructor is named after the class, the public cat. And now I'm going to put in the parameters what I would want to have those constructors take in. I think I want to have it take in the name. I'm going to take all of those things in there. And this is where we use the this. So this dot name equals name. So we're referring to ourselves here. This dot, you can go breed equals breed. This dot age equals age. And this dot color equals color. So now then we can access, when we're creating our cat constructor for this particular cat, we will have the ability to name this cat, have a breed, an age, and a color, all associated with just this one object. So if I create another cat, it can use the same variables, but when I use the this operator, it will apply those to the secondary cat object. All right, so now I have these here. I'm going to try something which is generating getters and setters. So underneath source, we should be able to generate getters and setters. I'm going to go back to that real quick. So under source, generate getters and setters. I want it for all of these. And I'll make them public. And I'm going to generate. So right there, I was able to generate quite a bit of information here. We have get name, get breed, set breed, get age, get color, set color. Okay, we've got all those. We do need a toString method to print that out. So let's try that next. Public string, toString, and I'm going to have in there a return. That'll help with that out. And this is what I wanted to return. Maybe say like, hi, my name is plus this dot get name plus period slash n my breed I'm just going to kind of put those together real quick. Get breed plus comma plus this dot get age. Age, color. Boom. Okay, so I'm not sure if I got that completely right. As I run this program, we will definitely make sure to find out whether or not that is a good toString method. Okay, so we have ourselves a cat class. Next, I'm going to be making a dog class. Referring to our instance variables for our cat class, I did forget to put the private term in front of those. So we want to make sure that you do that. Okay, moving on to dog class. So I've created something here like this for dog. We're going to do another one for some other animal, and then we'll create a farm class. Okay, so with this dog class, it's going to house very similar information. So I'm going to grab that information right here and just copy it over because it's going to be very similar. And I don't want it to be cat because obviously this is a dog class. However, everything else I really think should be about the same. Looks like I might need another one of these here. Boom. Okay, so right. Okay, now I'm going to get my generate my getters and setters underneath source. I want them for all of my attributes. And now I have these getters and setters for each one of those. I do want to do a real quick toString after the set color. Age, breed. Oh, I think I probably want to do name, age, breed, and color. The last one is going to be color. Okay, something like that could work for a toString maybe. We'll see how it works out. Alright, so that would be my dog class. I'm going to create one more here. Let's go right click on that same program and create a new class. And I'm going to make this one a goat class. It will not have a main method in it. And I'm going to do a lot of the same things here, only like that. Goat. Now I'm going to generate. Wait. Generate getters and setters. Select all. I saw that last time. Boom. Okay, good. And I'm going to grab that toString here and see if that works as well. Put it in my goat. Now I need to create a farm class that is going to have all of these objects on there. So it's going to be a farm class that I'm going to create next. Okay, so I have a farm class here. This one does have your main method in it. This is where you're going to run your program. So the other ones are supporting classes. This is your farm class with a main method. So let's create some objects here. Let's create a dog object. So dog, we need to name it. Let's say D1. So dog D1 equals new dog. And we have to refer back to our constructor here in name, breed, age, and color. Those are the parameters that it needs to have. So there's 4 of them: name, age, breed, and color. So right here. So on our new dog, we'll put the parameters. We'll put a name. Let's put Steve maybe. Age is 5. Let's take the type. Maybe it's a pug. And let's say that it's what was our last one? So name, age, breed, and color. Let's go brown. Now, I said I have issues here. Maybe I've got those backwards. So let's see, name, breed, age. Good, I'm so glad that this catches it for me. It does say swap arguments 5 and pug. Perfect. Okay, so I've got a dog object I'm creating. I could create 2 of those, or 3 or 4 or 5, or however many that I want. I don't need to necessarily do that for this example. I'm going to create a cat object. I'm going to say it's C1 equals new cat, and it has the same parameters in there. So this cat, let's say its name is Kitty, and it is a ragdoll cat that is 6 years old, and its color is, let's say, white. So now I've referred to a second class, and let's do our third one. Let's do a goat. Goat G1 equals new goat, and its name is going to be like Abe, maybe, so the goat sounding like that. And it is a, I don't even know types of goats. Mountain. It's a mountain goat, and it is 4 years old, and it is also white. Okay, so now I've created 4 new objects: a dog object, a cat object, a goat object, and now we just need to maybe print them out. So I'm going to go print them out, syso, and I'm going to say, just say the leaders of the pack are, we're going to go D1.getName plus, let's put a comma in there, C1.getName, and let's put a comma in there too, and then G1.getName. Okay, so I'm going to get the dog name, cat name, and goat name. Let's run this and see what happens. Okay, the leaders of the pack are Steve, Kitty, Abe. So it has successfully gone back into the subclasses and grabbed the information for that. Now let's talk a little bit about encapsulation. Watch this. If I go to my dog object here, instead of making it a public object, I say it's private. Okay, now that I go back to my farm class and I run this, it's going to have an issue here. It says farm line 7. Line 7. So this dog here has not been, it says here, change visibility of the dog. So we're going to go back here, change its visibility to public so that other classes have access to it. I'm going to go back into my farm class, rerun it, and it should grab those. Okay, so you're going to be creating a class of your own with some subclasses so that they work together. You can do one for a sphere, maybe playing cards. You could do cards and then a deck, coins, or a one that you would like to do on your own. So you write a driver class with supporting subclasses. The driver class has your main method in it. The supporting class has your other getters and setters methods. Okay, so here's your terminology for this particular lesson. Class, object, attribute, method, constructor, encapsulation, instance variable, local variable, scope, parameter list, return type, and visibility modifier. If you don't know what those are, go back through your slides so that you have a good understanding of those terms. Okay, so that's a quick overview of your writing classes, PowerPoint presentation, and coding examples. Thank you.